So thus far we've talked about general metric measurements. We've talked about measuring length, calculating area, measuring volume, using water displacement, using math. We're going to move on and talk about another property we often measure, and that's mass. So, could anyone think of what is the definition for mass? Tyler?
How heavy something might be, whether you're holding it or putting it on
Okay.
something.
Not bad. Sean?
The capacity an object takes up.
That's volume, right?
Mass. It's weight.
Yeah, that kind of goes along. So, if I have here, you guys were measuring these earlier. I have here two rectangular solids. Okay? This aluminum one and then this block of pure gold. Okay. And do they have the same volume?
Yes.
Do they have the same mass?
No.
You remember picking them up? They do not. So what is actually different about this block of pure gold compared to this block of aluminum? Elizabeth? Yes. Why? They're both metal. They're both the exact same volume. Why is this one heavier? Ashley?
One's denser.
Yeah, which? The block of pure valuable gold or the block of aluminum? The gold. So it has a greater mass in the same volume. Mass is the amount of matter in an object. That's the definition that we're going to use. The amount of matter in an object. And so when we're talking about physics, or any science, we have this law called the law of conservation of matter. It also applies to energy. And this law has three parts to it. The law says that in the universe, you cannot create new matter. You also cannot destroy matter or energy. So then what the heck can you do? Ashley?
Just change it.
Yes, you can change it or transform it. Well, if I take a piece of wood and I burn it, aren't I destroying the matter it's made out of?
No. Release it back into the air.
Right, I'm not actually destroying, I'm changing it. You know, much of the material that made up the wood is released in the smoke. Some is left over in the ash. But it's the same amount of matter, either one. What if I boil a pot of water and I completely boil it away? Have I destroyed the water molecules?
No.
No. I've changed them into the form of a gas. But it's still the same amount of matter. So we cannot create or destroy matter, but we can transform it. And so that's an important principle in physics. So when we measure mass in the metric system, our base unit is grams. A gram is about, like if you have one standard kind of pen with a cap on it, about the mass of the cap of the pen is about a gram. We often will use kilograms when talking about larger masses. A kilogram is 2.2 pounds. And then milligrams are often used for small measurements, medicines and sometimes nutrients, things like that. And a milligram is obviously 1/1000th of a gram. So the tools that we're going to be using to measure mass are a couple different things. We'll measure using this tool. Have you guys ever used this? This is called a triple beam balance. Now, how many of you have used this before? No?
Oh,
Something
I've seen
similar.
like those old-fashioned weight scales, like when you go to the doctor's.
Okay, yeah, sometimes you go to the pediatrician, depending on their technology. They might have one of those old scales where they have the weights and they slide them
Yeah.
until it balances out, and then they read them, tells you your weight. That's how this works, same thing. It uses these sliding weights. Your object you're measuring goes on the pan, and then you slide these weights until it balances out. That's how you use this triple beam balance. Okay? So here's another version. When you look at the parts, the part where you place the object is called the pan of the balance. These weights that you slide back and forth, those are called riders. Our balances have 3 riders. That's why it's called a triple beam balance. There's also a knob over here under the pan that you use to adjust and be sure it's calibrated. It's called the 0 knob. And then the part that has the pointer on it that you're trying to get aligned to 0 when you're measuring an object, that's the pointer. So to use a triple beam balance such as this, the procedure is pretty simple. You start by making sure our balance is what we call 0, which means we set all the riders at 0 and we look at the pointer. It should be pointing right to the line. This one's off, way off. This one, the pointer is well above the mark where it should be. So to get it in calibration, we turn this 0 knob. So if we turn it down, that's going to bring the pointer down. If we turn it up, that's going to bring the pointer up. So I need to bring the pointer down quite a bit. So I turn the knob, then I let it sit, and I see if it's balanced out. Quite a little more. A little bit more. Now it should be pretty close. And so now that it's 0, I can place an object on it. And now I start moving the riders. Start with the biggest one. Now, these 2 riders, the 2 largest ones, they have like a notch. They have to be in the notch. So if I move this 100 gram rider to the next notch, it goes all the way down. So what do I have to do? Tyler?
Go to the next smallest one.
So I have to go back. All right. Then I go to my next weight. I move it, keep moving it. Goes all the way down. I got to go back one. Go back 2. I'm almost there. Now I'm on my last rider. This one doesn't have notches. This one just freely slides back and forth. So I move that until it reaches the 0 point. I went too much. Really should be on the other side doing this. Just slide up until it's about to balance out. You want the line pointing right at the 0 mark. And once it aligns, you can read it. So what do I have to do with these different sliders, Colin?
See where they're like marked, like where their markings are, then add them.
Yeah, you add them all up. So the biggest one here, it's on 0, so we don't worry about that. This one, it's on 60, and the smallest one is on 1.5. So the mass of this is 61.5 pickles, grams.
Could it be people?
Pickles aren't the appropriate metric unit of measurement. All right, sometimes we might measure something using a digital balance. Here's an example. This is a digital balance that I have up here. Okay. They're a little quicker, obviously, to use. You know, riders doing all this stuff. And the procedure is pretty simple. First, you turn it on. You have an on-off button. Okay, this one is not plugged in, so it doesn't work. But you turn it on. Okay. There's a button on here that says 0. That sets the reading to 0 when there's nothing on the pan. Okay. And then there's the display. So you set it to 0, place your object on it, and see what it reads. Really simple. Now the nice thing about this type of balance is if I wanted to measure something like a liquid, I can take a container, so obviously I can't pour the liquid onto the balance, right? That doesn't make sense. But I can put a container on there, it'll read something, then press 0, and then add my liquid to it. And the reading will tell us the mass of just the liquid that we added. So it's a convenient way, it sort of does the subtraction for you rather than measure the mass of gold and subtract. So let's just look at a couple examples. Here I have a little diagram showing the riders of a balance. So if they were in this position, raise your hand if you can tell me what is the mass being indicated in this one. Sienna?
175 grams.
This one is 175 grams. You just add up each rider. And how about the bottom one? And up? 328 grams. Yeah. Yeah, they're just a little off. All right. Now, some of you mentioned weight earlier. So really, mass and weight are technically not the same thing. One of them depends on the other. Do you know which depends on which? Yes, weight depends on mass. All right. So we already said that mass is sort of how much stuff, the amount of matter in an object. It does not change when you move the location of an object. I have this chunk of solid valuable gold. It has a certain mass. If I take this chunk of gold to the moon, will its mass change?
No.
Here, yes or no?
No. It's no.
Will it be made of less matter on the moon?
No.
Will it have the same number of molecules in here? Yeah. Its mass doesn't change depending on its location. Well, what about its weight?
Yes.
Will this weigh a different amount on the moon?
Yes.
No.
Yes. Oh, wait, no, well, it depends on the gravity. It's not really the weight. Exactly. Changing. It's the gravity changing.
So what is weight dependent upon? Weight depends on a couple things.
Oh, wait, no, yes.
What does weight depend on? The mass and the force of gravity. And the force of gravity does change with location. All right. So, weight is a property that's determined by the mass of an object and the force of gravity pulling on that object. A simplified formula, it's not quite accurate, but to say the weight is the mass of the object times the force of gravity. What units do we use for weight? No, that's mass. Mass is grams and kilograms and milligrams. Sometimes they're used interchangeably on Earth. Technically, the metric unit for weight, which is a force, is newtons. Named after not Fig Newtons, but Isaac Newton. Sir Isaac. I apologize for not using the appropriate title. Yes, Sir Isaac Newton. And gravity and weight depend on a couple things. The size of the object and the distance from the center of the planet exerting that force of gravity. So we generally think about gravity in relationship to planetary bodies. But technically, any two objects in the universe have an attractive force due to gravity. But often it's very, very small. But a huge object such as the Earth, the Moon, the Sun, the Death Star, they all have a force of gravity. So, the larger the planet, the greater gravity it has. So, gravity on Earth compared to gravity on the moon. Earth, moon. Picture?
Can you go back a slide?
Here?
Yeah. Here.
May I continue now, students?
Yes. Yes.
Tell me when you're ready. Whatever
Yes.
schedule you guys need, I'm just here for your...
Thank you.
Yeah, you're welcome. You're welcome. I hate to rush you. Are you ready?
No.
Oh my God. 3, 2, 1, and change. All right. So gravity on the Earth, that's no moon. And got it. Thanks, one person. So we have the Earth and we have a moon. How does the gravity on Earth compare to the moon? Raise your hand, please. Sean.
Is it greater than or is it greater? Well,
It is greater than. Gravity on Earth is greater than the moon. So an object's weight on Earth is greater than its weight on the moon. Ali, how about the mass on the Earth versus the mass on the moon?
equal?
Yes, they are equal.
What did I do?
How about Jupiter versus the Earth?
Greater. Greater than.
The gravity on Jupiter is greater than gravity on the Earth. So, if you go to Jupiter, your weight is going to be
Almost double.
greater. How would the mass be on Jupiter? The same.
No. That is a highly inaccurate depiction of the
That's
size.
okay. Ali, where are we going?
I'm not going to say that figure.
Oh, okay. All right, so say Mr. Arcuri wants to go on a diet. He feels like he weighs too much.
Where was our period?
Where could he go to quickly decrease his weight?
Oh, the moon.
Not the fitness mill?
The moon.
The moon? Where else if he wanted to stay on Earth?
Mountaintop.
Yes. He can move to the top of a mountain. On the top of a mountain, there is less gravity than there is in a valley. Why? Because it is farther from the center of the Earth. Therefore, Mr. Arcuri and his instant diet weighs less on the mountain as opposed to in the valley. So, as a summary, now, I don't love how this is phrased. Your mass never, is that actually true? No, because as you're growing, obviously your mass is changing because you're adding material to your body. But thinking just momentarily, your mass doesn't change with your location, but your weight does change with your location. All right. So what is gravity? How does gravity on the moon compare to the Earth? It is less than. It is about 1/6. The gravity on the moon is about 1/6 the gravity on Earth. So if your mass on Earth is 70 kilos, what's your mass on the moon, Tyler?
Oh, 10.
Why should Tyler not need so long to figure this answer out?
Because the mass stays the same.
Because the mass stays the same. Mass does not change with location, but weight does. Your weight on Earth is 697 newtons.
Then you're pretty.
Maybe, maybe not. What is your weight on the moon? Did the math already?
1/6 of that.
Yes, true. Which is an actual number that we can calculate. If only we brought our calculator, if only we were holding it in our hand, we would be able to calculate it, Colin.
Yes, you would, Mr. Duras.
Wouldn't that be wonderful? Wouldn't you love to be able to provide me with that answer,
I would
Colin?
love to. It would approximately.
Approximately or exactly?
Exactly.
No, because it's just about 1/6.
About
Thanks, Mr.
Oh,
Ross.
you caught me. What do you got?
I don't know.
Oh my gosh.
Come on. I don't know.
Need another English management session this
We just do
afternoon.
it.
Yes, Jake.
116.2.
Yeah, so around about 115 newtons.
Yeah.
So remember, your mass changes the location, and your weight changes the location, but not your mass. Tyler, question.
I went to a museum and they had like a bunch of soup cans, and some were heavier than other ones.
Yeah.
And it was like if you were on the moon, the soup can
Oh.
would weigh this much.
Oh, that's
But
interesting.
if you were on the Earth, the soup can would weigh this much.
And was there a
You
big
would, like, pick
difference?
'em up.
Like how, like you could definitely tell, huge difference. Yeah, I guess we're gonna run out of time, but tomorrow I'll show you some of these videos about what it's like. Your homework is just to finish your lab. All right. Where do you need to go? I'll leave that question for tomorrow. New chance. A new chance for tomorrow. Since nobody got it right. I've checked them 100 times.
Wait, they're running. Wait,
Let me tell you this.
do you have like
The
pictures?
legs of that table are cylindrical.
What does that mean?
They are cylinders.